Okay, this is Algebra 2, 3.1, Part 3, Elimination. So we've done graphing, we've done substitution, this is your elimination part. So the very first problem that we're going to do is 4x minus 3y is equal to negative 22. And the second equation is 2x plus 3y equals 16. Very first thing you have to check with is on elimination is that your x's are lined up, your y's are lined up, your equal signs are lined up, and the numbers by themselves are also lined up. Then you look at the variable that has the same numbers, first of all, if you have that, and in this case we do, so they both have 3y. Then you look at the signs. Are the signs the same or are the signs different? In this case we have different signs, so different signs mean we're going to add. So back up to this same sign subtract, if they would have same sign subtract, that's how we remember that, SSS, and then different signs add. So we're going to add the two equations together. This gives me 6x, this cancels, and I get negative 22 plus 16, which is negative 6, divide by 6, x is negative 1. Then to find your y, you plug this back in. So we plug negative 1 back in for x, so 4 times negative 1 minus 3y equals negative 22. So you have negative 4 minus 3y equal negative 22. You add 4 to both sides, you get negative 3y equals negative 18. Divide by negative 3, y is 6. To verify your answer, you would plug in negative 1 for x, 6 for y, and in the first equation, you would want it to give you negative 22, and in the second equation, it should give you 16. The second equation we're going to do for the system is negative 6w minus 8z is equal to negative 44, and 3w plus 6z is equal to 36. So everything's lined up, and in this one, none of them have the same number. So what we're going to look at is, well, is there anything that I could multiply one of these equations by to give me the other thing? And so in the second equation, I could multiply this by 2, the whole thing by 2 to keep my equation balanced, and then my 3w would then be a 6w, so it would match. So I bring the first equation straight down, and then I multiply this one by 2. Everything gets multiplied by 2. Then I look. I have the same number in front of the same variable. I have one's negative, one's positive. They're different signs, so I'm going to add. Negative 6 plus positive 6 cancels. Negative 8 plus 12 is 4z. Negative 44 plus 72 is 28. Divide by 4. Z is 7. The way you put your numbers, if it's not x and y, is alphabetically. So z would be the second thing, and it would be the last thing in the alphabet, so w, then z. We plug 7 back in, and plug it into one of these up here, plug it into the new ones, it doesn't really matter. So I'm going to pick the 3w plus 6 times 7 equals 36. So 3w plus 6 times 7. Subtract your 42 over. Divide both sides by 3, and you get negative 2. So again, one solution crosses at negative 2, 7. Our next equation, we have 8a minus 3b equals negative 11. You have 5a plus 2b equals negative 3. On this one, none of them match up the same. I can't just multiply one and get the other number. So on this one, I always choose the one that I'm going to have to multiply the smallest number with. And so I'm going to multiply the whole thing by b. And so I want the b's to be the same, so I'm going to multiply the top by 2 and the bottom by 3. That would give me small numbers to work with, and they'll be easy numbers to work with. So I have 16a minus 6b equal negative 22. On bottom, I have 15a plus 6b equals negative 9. Looking at the b's on this one, they have different signs, so we're adding. So we get 31a, this cancels, equals negative 31. So we know that a is negative 1. Plug it back in. So we have negative 5 plus 2b equal negative 3. Add 5 over. 2b equals 2, so therefore b equals 1. Let's do another one. 5a plus 15b equals negative 24. Negative 2a minus 6b equal 28. So this one again, you can't multiply one of the numbers and get the other ones. So I'm going to work with the a's. In this case, multiply the top by 2 and the bottom by 5. We get 10a plus 30b is negative 48. And then you have negative 10a minus 30b equals 140. Some of you could probably see the answer from this point, because when I add this together, this all cancels, and I get 0 is equal to 92. Well, 0 is equal to 92 is a false statement, so then I write no solution. If you remember back to the first video, no solution problem means these two lines are parallel and they will never cross each other. The next question, 3a plus 5b equal negative 27. And 4a plus 10b equals negative 46. Now this one's probably is kind of easy because I can multiply that top one by 2 so that they both become 10. Now if you didn't see that, you could cancel a by multiplying the top by 4 and the bottom by 3. So let's start by multiplying the top by 2. So on this one you can see that they have the same sign. So same sign, subtract. We're subtracting the entire equation. That wasn't a very straight line, but that's a little bit better. So 6a minus 4a, so we have 2a. 10b minus 10b cancels. Negative 54 minus negative 46 becomes negative 8. Divide by 2. A is negative 4. Plug that back in. Doesn't really matter which equation. I'm going to pick the first one. So you have 3 times negative 4 plus 5b equal negative 27. 3 times negative 4, so we have negative 12 plus 5b equal negative 27. Add your 12 to both sides, so you have 5b equals negative 15. Divide by 5, and b is negative 3. One solution, 2 lines across, negative 4, negative 3. Our last equation we're going to do is 9y plus 3x equals 18. And we have negative 3y minus x equals negative 6. So if I notice if I multiply this by 3, it gives me 3. If I multiply this one by 3, it gives me 9. And so when I multiply, if I multiply that negative 3 by 3, it also gives me not, well, it could give me negative 5, but I'm just worried about the number right here. So it gives me 9. So on this one, if I multiply by 3, something cool is going to happen here. I get negative 9y minus 3x equals negative 18. Well, they have different signs, so different signs add. This cancels, this cancels. This over here is supposed to be 18, not 16. cancels, and we have 0 equals 0, which is a true statement, which means our answer would be infinite solutions. Okay, not infinitely many, because not everything works. Infinite number of solutions. Okay, not all real numbers, nothing like that. Infinite solutions, because there's an infinite amount of solutions. Not all numbers are a solution. There are just infinite amount of solutions here. And so, which means these two lines are the same line. They, when you graph them, they are graphed on top of each other, so they touch at every single point. And that concludes 3.1.